Awesome. Yeah, let me just stand beside this. So hi, everyone. Good morning. And first of all, thanks for being a part of this meetup. I guess this is my first time speaking at a Neo4j graph database meetup, especially in Bangalore. So yeah, let's get started with this session. It's all about like testing AWS serverless integrations with Neo4j using localstack. These are some big words, but I guess we'll just delve into that and we'll see like what it's all about and how you can just simplify the whole process. So I'm Harsh, as mentioned on the slide. I work at localstack. It's incidentally my first job out of college. So yeah, just happy to discuss about a lot of things that I have been going on over here. Thank you. So yeah, some basic agenda points. I guess we are going to start with some introduction and background. My own personal experience with Neo4j, like almost 4 years back while I was working at a startup. Then we are going to jump into cloud development and testing on AWS. It's totally OK if you're not experienced with AWS. It's totally transferable on any other public cloud provider. We are going to talk a bit about localstack, the open source core project that's behind this whole product. And then we are going to showcase like how you can integrate your Lambda functions with Neo4j and pretty much run them locally. And yes, we'll wrap up with some basic conclusion points, and we can just do a basic Q&A. So I had this audience participation. I was expecting like 40-ish people, but I guess since we are a small crowd, then we can just dive in really quick. So you can basically navigate to slido.com. There are just 3 basic questions. If not, you can just raise your hands up. I guess it's totally all right since we are a small crowd. It's more concentrated that way. There is a QR code, by the way, over here. So you can just scan that, and this will give you entry into the whole Slido session. Just 3 basic questions. Won't take more than half a minute or so. So are we good to start? Awesome. So I guess the few questions that I had is, sorry about that. Yeah, what best describes your role? Like, are you a professional application developer? It can be cloud, database, software. You're learning about application development. You manage an engineering team. You're in higher education or maybe some other option. OK, so a lot of you are professional application developer. Some are learning about it. Some are in higher education. That's quite good. It's a nice ratio over here. So jumping on to the next question. What public cloud provider you have worked with? I guess the most important part of this whole session. So is it AWS, GCP, Azure, any other option? OK, so we have a good number of people using AWS over here. That's pretty nice. What kind of AWS services you're using? Any examples? I guess I know about them since I had a talk, but anyone else who's using some particular AWS service? S3 buckets, that's cool. Maybe I can just go ahead and make it quick. And yes, have you heard about localstack before? I guess the answer would be an overwhelming no. That was pretty evident. That's the whole part of the meetup. But yes, I guess I got a pretty good idea about what this talk is exactly going to be. So yeah, thanks a lot for participating in this Slido session. So maybe let's jump into my experience with Neo4j. So 4 years back, I was kind of doing my first software engineering internship. And this was at a company called as QXF2. It's a chess move. And it is simply because the founder loved quite a lot about chess. So it was a quality assurance startup, and I was hired to basically work on one of their feedback management systems. So every Friday, their employees used to go on this feedback management system. And they used to like run down a few questions. So it was like, what have you learned the last week? Who exactly you have helped out? What persons have taken help from you? Things like that. And all of this was basically stored in a SQL database. And at the end of the day, a report was generated, and it was shared with all of the employees within the company. So I was asked to basically redesign and re-engineer the whole system. And for this, we were supposed to use Neo4j, because Neo4j had this whole graph database properties. You had nodes, you had relationships, and all of these kind of things. So it was kind of perfect for the role. So we built the application, and now for the report generation part, what was required from us is to write a Lambda function that reads your Neo4j database, queries the whole thing, generates a report, and push that to a Skype channel that we were using. Now this is the part where the trouble started. The full stack application was pretty much running locally. The Neo4j developer experience with the whole desktop app was pretty good. The front end was built using React. The back end was built using Fast API, and so on. But when I started testing this whole Lambda integration with Neo4j, it was so difficult, because we were like writing the code, pushing that to the AWS, executing it over there, and there was like a couple of exceptions happening over and over again. And it was such a difficult thing to tackle over there. And it was at this time, my manager, who was also the founder of that company, he mentioned to me a tool, and I had no idea that I would be working for the same tool maybe 2 or 3 years later. So that's how I started with LocalStack. So coming on to the area where we are with the cloud right now, I guess there are 3 main ways where people are using cloud. There is the whole infrastructure as a service, and this is where you use services like EC2, or maybe if you're using GCP or Azure, there are services like App Runner and things like that. Then you have container as a service. So if you are basically packaging your entire application in a Docker image, you can basically use things like ECS or EKS to basically deploy your whole application as a container itself. And thirdly, we have got the serverless integration. So things like S3 buckets, Lambda functions, event bridge rules, DynamoDB tables, SES, SNS, SQS. I guess the names are pretty endless. But more broadly, these 3 are the ways where people are actually developing and testing on the cloud. But it has got so many troubles. I guess I just described like the trouble that I was facing with developing and testing Lambdas locally. But if we just take the example for any other cloud application, if you're starting up with building a cloud application right now, you will suddenly realize is that there are so many dependencies that you don't have any control over. So there are things like databases, virtual machines, message queues, S3 buckets, things like that. And slowly you will feel a bit overwhelmed with all these resources that you have to manage, you have to handle. And suddenly you will start realizing that the cost is spiking up and the whole deploy time is quite long. So in this use case, like Alice managed to resolve the dependencies. She managed to get her cloud resources configured. But when she started deploying on the cloud, it is now taking so much time. Like ideally, if you're trying to deploy a full-fledged application, it takes anywhere between 20 to 30 minutes on an average. It depends on the context, but that's the general use case. And suddenly she will start realizing that there is a very slow dev and test loop. So this whole developer experience is quite a necessary factor, because if I am building an application, what I would expect is that every time I save my code, I should expect like a split-second result about what the code is actually doing. If I have to wait for it to be deployed on the cloud and then to start testing, it's just going to slow me down, and it's going to slow down the whole development process. And on top of this, there are a lot of troubles. First of all, you might be thinking, like, why cannot I attach an ID? Like, why cannot I attach a debugger from my ID? How do I debug my serverless functions or some of the cloud resources that I have created? Another time, you will realize that the logging is not enabled. So this means that you have to redeploy the whole application again from the scratch by destroying all those resources. You have to enable the logging, and you have to find out about what exactly is going wrong. And on top of this, there are some more obscure errors, like something is gone wrong, or maybe a CI build is failing. So now you want to go back, you want to see like what's exactly happening. And many a times you will not exactly find like any solution whatsoever. So this is the reality of the cloud developer experience right now. And this is something that I guess a lot of people might be facing. I faced this almost a couple of years back, and a lot of developers are still facing the same issue like across every major cloud provider right now. So if you want to understand like how you can test your cloud applications, so there are basically 4 areas where you can test your cloud apps. The very basic one over here is simply mocking. I guess you can just mock out your cloud APIs. You can like write your own mock classes, and that will give you a sense of what exactly my application is interacting with. This is a very general like feedback loop that a lot of people go through, is that they just use some mocking tool, or they basically write their own mocks, and they get a sense that, hey, my cloud app is running fine. Maybe it won't blow up in the production. Maybe. That's the big keyword over here. The second part is service emulation. So it's not exactly black and white. A lot of the public cloud providers have been providing these service emulators. AWS has got something that's called as DynamoDB local, step functions local. Azure has got something called as Azurite. There is also this Cosmos DB emulator, things like that. And this basically allows you to run these local version of these services on your local machine and get a sense of how you can play around with them and how they exactly work. But the problem, again, is that they do not have any infrastructure as code support, so no Terraform, CDK, SAM, or whatever you're using. They do not exactly have the API parity like the real cloud service. For example, DynamoDB local recently released their version 2 after many years. So you see, like, they might just create outdated, and companies simply won't care about it. The third step is the cloud emulation, and this is, spoiler alert, this is what LocalStack is all about. You can run your full cloud on your local machine. So this isn't just limited to S3s or Lambdas. It means that you can connect these cloud services together, and you can pretty much have a feel of how this application is running right on your local machine. And this is what I'm going to give a very simple demo about. But obviously, the source that is more close to the truth is the staging environment. This is simply where you actually deploy the application on the real cloud, on a staging setup, and you get a real sense of how your application is interacting and how it is basically working out. So yes, getting started with LocalStack. So what exactly LocalStack is? So LocalStack is a platform that is for cloud application development and testing. And what we are primarily working on right now is the AWS emulation. So I guess I had a talk with a few of you before this talk, so you might have a sense. Basically, LocalStack allows you to have a fully functional local cloud stack. So you can run your AWS applications pretty much on your local machine without having to worry about any of the things. So everything is running locally, which means that you don't have to deploy your applications on the real cloud. Everything is happening in split second because no real resources are being created. And on top of this, you're not spending anything on the real AWS because everything is being configured locally, everything is being run locally. So yes, we are a pretty popular open source project. I guess this is like more of our GitHub page right now. It has over 51,000 GitHub stars. So one of the most popular projects in the whole DevOps, cloud, and Python space. And we have been growing further with like more emulators, with more things over there. So yes, so LocalStack pretty much acts like a drop-in replacement for AWS on your local machine. So whatever AWS integration you're using, like AWS CLI or CDK or SAM or Terraform, you can pretty much replace your AWS configurations with LocalStack without making any changes to your application code. And LocalStack will just work fine. Your application will just work fine. And the best part is that your application won't even know the difference. Like it will be able to set up the same databases, S3 buckets, Lambda functions, all of the parts pretty much on the local machine itself. So why exactly LocalStack? The very first reason is that it enables a very efficient dev and test loop. Now you don't have to wait anything on the AWS for your resources to be deployed. You can create the resources, you can tear it down almost in an instant second. The second part is that it's shipped as a Docker image. This is something that we have in semblance with Neo4j. Neo4j has a pretty awesome Docker image that basically allows you to spin up a complete Neo4j database as a container. And it's pretty easy to install and start up as well. There is a pretty great support for AWS APIs, so it's not just limited to basic parts like Lambda or S3 or DynamoDB. It's also going into like RDS, TimeStream, MSK, and things like that. And on top of this, we have some extra collaboration features, integrations, things like that that I'll not go into this session, just for the sake of the time. But just to give you a very basic idea about how the architecture looks like, then this is how LocalStack is basically engineered. So we have the LocalStack core, and then we have the service emulators in them. So there are like Lambdas, SNS, S3 buckets, DynamoDB. How do we emulate them? Is that we simply write these services from scratch. So if there is a new service that AWS is providing, and now we need to emulate that, we need to support that, what we will do is like we will look at the AWS documentation, we'll figure out like how the service works, and then we will start writing them from the scratch itself. If you want to like explore that, you can just go to our open source code base. If I just give you an example, you can maybe search for Lambda, and you can check out like the AWS Lambda like code over here, maybe not this one. But yes, you can basically, I guess I'm in the test right now, but yeah, you can basically explore the whole open source code base and you can figure out like how this service emulator is written and how does this basically work out in itself. And yes, these service emulators are then connected to the AWS protocol. This is a framework that we implemented that's called as the Amazon Server Framework. We are not affiliated with Amazon, so just don't take the name on its face. But this basically means that this protocol allows these service emulators to have the same specification as a real AWS, which means that you can connect your protocol with whatever integration you're using, any sort of an SDK or CLI or Terraform or Pulumi or CDK over here. The interesting part over here that I won't be talking much about is the extensions. But this basically allows you to extend LocalStack, which means that you can build more emulators on top of it. So if you're trying to emulate something like Azure, if there is a special service in mind that you have, you can basically extend LocalStack on your own, and you can rewrite your own emulator on top of it. LocalStack gives you all of the skeleton that can make this entire thing possible. And from more of a 10,000 feet view, LocalStack is not supposed to replace AWS. Like on the real production, you obviously have to use AWS to some extent. LocalStack pretty much like works on your developer machine and on your CI pipelines. So it acts as a drop-in replacement, which means that you can just swap your AWS dependencies with LocalStack, and your application is just gonna work in the same way itself. So this basically has 3 advantages. The first one is the speed. You obviously get like a much nicer feel of how your application is deploying and setting up. The second one is the cost saving. You're obviously saving a lot of cost because you don't have to deploy and destroy the resources over and over again. And the third one is that the whole developer experience is nice. Like let us say that you are trying to work on a Terraform config, and that takes about like 20 minutes to deploy. With a LocalStack, that would be like almost reduced by a 10x factor. And this gives you a very nice feel about when something is going wrong and when something is going right and how you can fix some common bugs that you might encounter. So if you want to set up local stack on your local machine, it's pretty easy. There are just 3 basic commands. I guess I can just swap out the second one, and you can just go with the 2 basic ones. But you can just pull the local stack Docker image. It's shipped as a Docker image, so you will be able to start this as a container. You can install the local stack CLI. Again, that's completely optional. You can just say like docker run local stack, and this will start the local stack container on your own machine. And the second command is basically called as the AWS local. So I guess most of you must have used AWS CLI before for creating some resources. So this AWS local basically replaces that AWS CLI, and it allows you to redirect all of your AWS API requests to the local stack container itself. And yes, once you install local stack, you can just say like local stack start, or you can say like docker run local stack / local stack, and that will set up the whole container running right on your host machine. So there is not much of the things that you need to set up. There is no certain machine requirements that you need to satisfy. It's shipped as a Docker container, so if you have Docker installed, you will be able to use local stack to a great advantage. So just to give you a quick start about how local stack works, I have a pretty simple use case over here. But again, like we are not yet into our demo as of now. So what I will do is like I'll just use the local stack CLI to start my local stack container. So I hope the code editor is visible. Should I just increase the font size? It's OK? OK. So local stack container started up. It's basically being served on this localhost 4566. So that's the local stack edge port. And you don't have to specify any specific ports for different AWS services. Everything is basically rerouted from this edge port itself. And whatever AWS integration you have, you can just say that, just take up this AWS endpoint URL and just send all of the API requests to this edge port itself. So once this is started up, I can go to my terminal, and I have this quick start script. So what I'm going to do is like I'll just run these few basic commands. I guess most of you might be able to understand what's happening. It's creating an S3 bucket. It's putting a file into that. And basically, it queries the S3 bucket to see like what files are exactly available in this. And in this case, the hello world is created, the file that I basically made up. And if I go back to my local stack logs, you will be able to see that there is an S3 put object API call, there is an S3 create bucket API call, and there is an S3 list objects API call. So everything is happening on your local machine. Nothing is really being deployed on the cloud. And this gives you a pretty nice feel about how you can get started with AWS. So it's not just limited to S3. Like in this example, I also have for DynamoDB. It's a NoSQL database that AWS provides. It's pretty ironic to talk about NoSQL in a graph database meetup, but here we are. So we created a NoSQL database, and then you can pretty much put some items over here. So just gonna run through this. And then you can just scan this whole table right on your own. And this is gonna show you like whatever data items that you have inserted into a local DynamoDB table. The best part is that if you just shut down your Docker container, the local stack Docker container that I spinned up, all of the resources that I created will simply vanish because everything is ephemeral. It's all contained inside this one single Docker container. And once I stop this, none of these resources exist, which means that you don't have to go ahead and manually destroy them or anything like that. If I just go back over here again and I just query the DynamoDB table once more, it will just say like it could not connect to the endpoint URL, which means that the local stack container is stopped and all of the resources are simply gone away. So that was a quick and simple quick start. And yes, maybe let's jump into the actual use case that I just wanted to showcase. It's a very simple one, just for the sake of the meetup. But yeah, we wanted to showcase like how we can integrate Lambda with a locally running Neo4j database. So how many of you have used Lambda before? Any quick hands? I guess I don't need to explain quite a lot part into this, but just to give a very basic idea, Lambda is a compute service that AWS provides, and in itself, it's serverless, which means that you don't have to manually provision any specific servers. AWS provisions that for you, and all that you need to do is to just create these functions, deploy them, and just invoke them using some sort of an integration. I guess over here it's API gateway, but you can hook up your Lambda with any sort of other AWS service like Kinesis or S3 or SQS or SNS whatsoever. So over here, I'm going to deploy a Lambda function that connects to my Neo4j database, and I'm going to use something that's called as the Serverless Application Model, colloquially called as the SAM. And it's a very popular tool by AWS that allows you to define your infrastructure as code. By infrastructure as code, I mean that you can create your configurations and you can deploy them. And this will give you some extra advantages like version control, not going onto the AWS console and clicking like a lot of buttons and things like that. SAM has a basic advantage that it basically compiles into CloudFormation stack. So CloudFormation is the primitive nature of the AWS infrastructure as code service, and it is deployed such that itself. And basically, the whole SAM developer experience is more about giving an extended experience of the CloudFormation itself. So as I said before, LocalStack pretty much integrates with any other tool that AWS provides. So in this case, I have got something that's called as the SAM local. But maybe if I just go on my browser and I just search for SAM local, it's just a very, very similar tool to AWS Local. So AWS Local was a wrapper on top of the AWS CLI that redirects your API request from AWS to LocalStack. SAM Local pretty much does the same. It redirects your SAM API request to the LocalStack itself so that you don't accidentally create any real resources on the AWS. So we will be using this CLI tool to basically simplify this deployment against the LocalStack itself. And this is what the basic architecture we have. So we have a Lambda function. We have a basic record file that has got some events. In a real world scenario, this event record should be coming from some other external provider, like maybe Kinesis or maybe SQS or something like that. But we are going to manually upload this to our Lambda function. And this is going to insert these records into our Neo4j database. So maybe just to show you the code right now. Yeah. So how we are provisioning both LocalStack and Neo4j is using this standard Docker Compose file. So I guess most of you are familiar with Docker Compose. And over here, we are spinning up two containers. The first one is LocalStack, and the second one is Neo4j itself. So we are using both the LocalStack latest image and the Neo4j latest image itself. We don't have to set up like a lot of things. We just need to specify the ports where our container would be exposed. We need to set up some env variables. Like in this case, I'm setting the Lambda runtime environment timeout to 600. Just to ensure that my Lambda does not time out on my local machine. And over here, I'm just setting up the Neo4j auth, which is specified to a very basic username and password. Maybe I'll just increase the font over here just to give a basic insight. I'm also setting up a Docker network just so that my LocalStack container can directly talk with the Neo4j container itself. If I just go ahead to my Lambda function, it's a very basic one. But what we are doing is like we are just grabbing the Neo4j URI, the username, and the password from the Lambda configuration. And then we are basically executing a very simple Cypher query that takes up this Lambda event node and basically adds this date time and the event record to that particular node itself. Very simple, but just to showcase how you can run these integrations on your local machine. And the third file that I wanted to showcase is the template.yaml. So you can define your SAM applications using this particular template.yaml. And it basically allows you to specify all of the settings for your Lambda function. So in this case, I'm specifying that I want to deploy like a Lambda function over here. I'm specifying my handler to be the Lambda function directory and the Lambda handler that I have specified. The runtime should be Python 3.10. The timeout should be 600 and all of the necessary IAM policies. And I'm also specifying a Lambda layer. So this Lambda layer basically allows me to compile all of the dependencies into one single layer. And I can share this layer with any number of Lambda functions that I can deploy. So I don't have to specify this with my Lambda over and over again. So with this said, I guess now I can go ahead and maybe start the whole process of deployment. So first, I'm going to start my Docker Compose. So Docker Compose is starting up. This is going to start LocalStack and Neo4j alongside it. And once this is done, I guess it will just take like a few more seconds. Yes, I hope it is ready. So if I just go ahead, I can just run like a basic command to test if LocalStack is running. It is running, I guess. So we should be good. Once I do this, the first step that I need to do is to build my SAM application. So this is easily done using SAM local build. If you're using AWS, on the other hand, you can just specify SAM build, and this will set up the whole dependencies and all of the things for you. But in this case, I'm just pointing all of the AWS API requests to the local stack, so I'm just using SAM local in this case. And this is going to basically build my Lambdas, zip the whole thing, and make sure that it is ready to be deployed. The next step would be to SAM local deploy. And in this case, I'm going to specify like a guided flag so that SAM can basically walk me through the whole process. So I'm going to specify the stack name as the SAM app, the region as the US East one. I want to confirm the changes before I deploy, yes. I want to create the IAM role, yes. Disable the rollback, save the arguments, and rest can be pretty much default. So what this will do is like the SAM will basically synthesize the whole template that we had into an actual CloudFormation template. And this will start the whole deployment process right over here. So in this case, I can just go back to the other terminal And you can see like localstack has already started creating the CloudFormation chain set right on the local machine. So if I just go back once again, you can see that the SAM has basically created the whole stack chain set, and it has given me a very basic overview of what's exactly going to be created. So in this case, there is a function that's been created, there is a Lambda layer that's been created, and there are the IAM roles that the Lambda function pretty much needs. So I can go ahead, I can say yes, that I want to deploy this chain set. And if you try to deploy this on the real AWS, that's going to take you about 4 or 5 minutes because it's a simple example. But in case of localstack, it's going to happen in maybe less than 20 or 30 seconds at best. So yes, our application is basically deployed right now, I hope. And the best way to basically test that is to actually go ahead and check out the README. So in this case, I had some basic commands as well that I need to run. So maybe I can go to a different terminal. But I want to export this whole Neo4j password, the URI, and the username, and basically update my Lambda function to basically take them up as a separate configuration variable. Again, this is not a very good use case. You should be ideally storing this on some other service like KMS or the Lambda environment variables, because you want to like secure these kind of credentials on the real AWS. But over here, you're just developing and testing everything on your local machine. So this means that the Lambda function has been updated, and it has basically got the Neo4j username, the password, and the URI right over here. Once it is done, now you can go ahead and you can just simply invoke the Lambda function right over here. And over here, I'm just specifying the function name that I have already grabbed before. I have a payload file that is basically comprising of some Kinesis records. And I'm just specifying like I need to get the CLI binary format because I'm just using a pretty old version of the AWS CLI. But in this case, you will see that the Lambda function has been invoked. It has been executed. And if you actually go to the localstack logs, you will see one interesting thing is that localstack spinned up another container that basically mimics a real-world Lambda function to execute your code over there. These containers are provided by AWS itself. So what localstack does is like it pulls these containers from the AWS container registry. It executes your code over there on your local machine, and it gives you a pretty good idea about what's exactly happening. If I go to my Docker desktop maybe, you can see that there is a Docker container over here. And in this case, you might be able to see that the Kinesis records have been executed and it has been inserted into the Neo4j database. The best way to validate that is to, again, go to my Neo4j browser itself. Maybe refresh the whole thing. I need to specify the password. Let's hope this works. Yeah. And if you go to the database, you will be able to see that the Lambda events that I basically inserted as a payload is now part of my Neo4j database. So obviously, you can extend this base example furthermore. You can like add more Cypher queries. You can like do much more with your Lambda function. You can also bring in like more AWS services like DynamoDB or SQS, and you can like actually test your whole AWS architecture with Neo4j quite a lot, because many of the customers are adopting both AWS and Neo4j together. And I guess I was having a talk, and AWS itself seems to use Neo4j under the hood. So it definitely makes sense to bring your applications to your local machine as much as possible and make sure that they are well tested before you actually deploy them to the production. So what are the advantages that you get? The first one is that you have the reproducibility. Both localstack and Neo4j are spinned up as a Docker container, which means that you can just create these containers, throw them away, and have this rapid dev and test loop. The second one is the speed. Obviously, the speed is much faster than what you can do on the real AWS. There is a higher quality chance that you are building better software because you have this debugging, you have replicating bugs, and you have some other features that only localstack provides. And on top of this, you can basically remove the restrictions. A lot of developers do not have access to the cloud. And maybe it's not limited to startups, but maybe in government agencies or healthcare or some other sectors, developers are usually not allowed to use the cloud. And in their cases, you can just run localstack to have a real environment that at least mimics how a real cloud should basically look like. And last but not the least, there is obviously the cost factor. Nothing is really being spent if you're developing on your local machine. And this gives you a pretty nice idea about what's exactly working and what's exactly not. And yes, just wanted to end this with this one part, is that in this case, I just showed everything using using a Docker Compose setup and some other manual configurations that I did. But if you want to like write more high quality integration tests, in that case, you can use a framework called as test containers. I'm not sure how many of you have heard about it before. I should have added this as a slider link. Sorry, a slider question. But test containers is another open source framework that basically allows you to create these lightweight containers and just throw them away once you're done with your development and testing. And test containers is backed by this company called as Atomic Jar, which is now part of Docker. And they have this one program called as the official modules program. And over there, both LocalStack and Neo4j are kind of part of it. So basically, you can use test containers to orchestrate both LocalStack and Neo4j together. You can run your integration test, get a quick validation, stop your Docker containers, and your job is done. So with this, I guess I'm pretty much done. I hope I did not go over the time. But I'm open to any questions right now so that I can just answer them. Yeah.
I created something called localstack. Do I deploy that to cloud? Is there any easy way?
The easiest way is like, basically you have your SAM application, like just the one that I showed right now. So in that case, I use SAM local for my use case. I can just swap SAM local with SAM. I can just say like SAM build, SAM deploy, and this will deploy the same application right on the real AWS. So there is no change to the code that you actually need over there. All that you need to change is the base CLI or whatever configuration or whatever other provider that you're using under the hood. Yeah. Yeah.
Even though you run everything on local, you're still instantiating some services on cloud.
No, not at all. I can actually shut down my internet and I can still run those same services. There is some pre-downloading happening, like let us say that you're spinning up Elasticsearch clusters, Elasticsearch or OpenSearch or things like EKS. Over there, we actually download some artifacts from our own private registry because they're exactly needed to like spin out these services at the end. So yeah.
The only other thing is that you're pulling up.
Yes, it's pretty much running locally because you can like test everything on your local machine. You can see the API requests happening. And in some cases, we also provide like an offline image, which means that enterprises that work in a completely air-gapped environment, they can shut down the internet for their employees and they can still like continue to use the same features. So it has got all of the dependencies simply baked in inside one single Docker image. Yeah.
How do you keep the parity between AWS and your OpenStack?
Yeah, that's a pretty interesting question, I would say. I hope I'm not going over the time. Yeah, sure. But yeah, just to give one, I guess, just a basic overview, we basically, as I said before, we have something that's called as the ASF, so Amazon Server Framework. So we have this regularly running GitHub action workflow. And what this does is like every Monday, it will scrape all of the AWS APIs, their requests and the responses. And it will compare this with what LocalStack has, and it will generate an automatic pull request to kind of update all of these APIs over there. So if something is not implemented, that's obviously something on us. But at least you will never find something that AWS has and that LocalStack says like, hey, this API does not exist. It might say that this API is not yet implemented. And if this is something that's a blocker for you, you can let us know and we can kind of fix that on priority. Yeah. So just to end, thanks for being a part of this session. And yes, if you want to connect with me, I guess I'm available on all these platforms. And if you want to involve with LocalStack and the community over there, you can just join using this QR code or maybe using this link over here. So thank you all. Thanks for your patience. And yeah.